Get out. Where are you, magnetic pad? I thought I'd be attracted to you by now. Hey Jim, fix it. Ramirez. Hey Defcon. Greg, Andrew. I'll get to this in a bit because that's going to require a bit of a rewrite of the firmware code. I've got to get this fixed up. It was supposed to be earlier today, but we've been busy dealing with kittens. One of the kittens today seemed like they had something in their mouth or something like that. They were like constantly doing this, and we took it to the vet. They couldn't see anything. They gave an antihistamine just in case it was an insect bite or something like that. But even after it was there for a few hours of observation, it seemed like things were okay. Came back and then it started doing it again. So fortunately it seems to have settled down now, but as you can imagine it's quite disconcerting. So it's kind of drained a lot of our personal energy. Okay, it looks like this is... I didn't check with the customer to see if this is a previously replaced screen or not. Basically they've got no touch. No touch is occurring. And if it's an original screen, then I want to try and retain it entirely. Well, obviously, no matter what, I want to try and not cause any breakage. But it's actually holding pretty fast, so I have a feeling it might be an original. In which case that does cause me a bit of concern. So we're just going to heat it up, get that glue to loosen its grip a little bit. Yeah, might be good enough. Hey there, Vladimir. That's definitely feeling like an... Oh, yeah, feeling like an original. Elevens are precarious enough, the 12s are just so much worse. Just giving it a bit of a lick with the alcohol, it kind of helps get that glue to let go. Yeah, this feels original. It is original. Ah, that's problematic. Alright, first thing I'm going to try is actually just disconnect the battery and then reconnect the battery. Who knows, maybe it's had some kind of a brain fart. I might take the whole panel out though. Not sure why you would have got that def bomb. I mean, no, I'm running the Kona card again. I mean, the Black Magic gave me no trouble at all, but I did spend quite a bit on the Kona card, so I really do want it to work. I've been fortunate that they actually have been willing to... They're sending me a brand new replacement to replace the one that I had to rework, because their sort of typical policy seems to be if you have a faulty card, you send it in, and then they send you one that they've already repaired from a previous sort of person. So, it's a bit of an exchange program type thing, it seems. but the rework quality on the one that I received back was just so bad that I ended up one of the input channels just was green, like you had no other color hue. And I went digging around on the board because that's what we do. And sure enough, there was a couple of pins just floating in the middle of the air. But to be fair, the chips that they've used for the encoding, and they are like, I think they were 128 pin TQFPs, and those things are an absolute freaking nightmare to solder properly. It's bad enough if you have a nice factory controlled situation. It's even worse when you've got a human doing rework on them. Honestly, I'd rather do an SMC than one of those big fat TQFPs. They are terrible chips to manually work, in my opinion. Hey Gavin Brown, not been around much, just to order a JBT 50 watt fiber laser to go alongside. Oh, well, you're going to be having plenty of fun. Well, Defrom, I agree. So I don't know where they get their rework done, but it was pretty bad. A lot of residual flux. Okay, that's not the worst thing, but like I said, 3 or 4 pins were just flopping on top of the pad, so I scratched it back and reworked it. And the support personnel said, you shouldn't do that, you ruin your chances of a warranty. And I'm like, really at this point, it's been over a year, I'm still having troubles with this thing. Alright, that's interesting, it's actually working now, so I don't know whether it got itself into a brain fart. Yes, that's fine. I don't know whether it got itself into a brain fart and needed the battery reset, or whether there's something else that's going to manifest later. Hey there, Lacanimal, or whatever your name is. Can't pronounce that too easily. Okay. I'm not a fan of the way that Apple did the retainer plates on the iPhone 11, because you essentially are forced to have to disconnect your screen before you get a chance to disconnect the battery. You can do it, but you put a fair bit of strain on the display connector trying to get this retainer plate out. So I don't know why they've done it that way. I don't know whether they even cared. I mean, sure, once you disconnect the battery, it goes into a quiescent state, so it's not really going to be drawing much until you power it on. But I still don't like the notion of there being a energy source connected to the board while you're fluffing around with everything else. Yeah, it just doesn't sit with me very well. I know there's plenty of people who've done screen replacements and everything like that with the power on. I mean, iPads, you almost always inevitably end up doing digitizer replacements and there's still the battery connected. Obviously, you try to avoid it if you've got a situation where the screen is actually on, in which case, yeah, you're going to want to put take the screw out and put a divider between the battery and the contacts. But yeah, that's precarious in its own way, because you can bend those pins like animal. Okay, cool. Oh, 9-inch nails. Okay, yeah. Hey there, John L. Hey, Craig. Oh, Craig. Yeah, yeah. Something of yours turned up today, by the way, indirectly through someone else. And yeah, I'm gonna shove it where I can. Okay, thank you very much, Craig. I got that message. Good old 9-inch nails. I remember going into the clubs in the mid-90s, and that was a very popular choice. Hey, Mark II, doing well. Yeah, well, I'll give this back to the customer and just tell them, see how you go. I might clean out, this is going to be perhaps a mistake, but I'm going to clean out the earpiece because it is choked. See, Defcom had a win. Designers. Oh, I saw that on Twitter. Yeah. Oh wow! Would you believe it? It's now not working again. Okay. What a pain in my backside. Alright, spoke too soon. It's not working now. I wonder if we've got a bad pin or something like that on the display connector. I would really ideally prefer to retain the original display. Are there any issues changing an iPad 7 screen? There shouldn't be, no. They're pretty straightforward. The 5, 6 and 7 and 8, they're all pretty much muchins. There's some sort of slight variances between them, but in terms of actual procedure that you follow, it's all pretty much the same. Naturally, of course, this happens after I have sealed it all back up. Sometimes it can just be a battery reset. Yeah, the iOS gets itself into a bit of a tiz. But this clearly was not the case. I am going to have to disconnect the battery again. Get careful on this screw. If you go too hard and fast, you can... I actually disassembled it the wrong way. I really should be going clockwise from there, and that way you avoid that last screw pivoting the whole retainer plate, which can then in turn, of course, cut cables. Alright, let's have a look at these. Like I said, there is a bit of deformation on there. You can see a bit of, it's got a little bit of a bend in it. Oh, I just noticed that. That's interesting. It's a complete delamination there. To be honest, I don't know which one is... Yeah, that's complete delamination. That could be potentially a cause. I have a suspicion that this is the touch connector because it is the biggest connector, and contrary to perceptions, the screen connector is actually smaller. And that would not have been through me because I'm left-handed, so my extraction point of attack is over here on this side. So yeah, that, I don't know why that's delaminated there. Fix it. Feel free to put down your Discord server. Alright, so we'll just suggest to the customer new screens needed, but I don't know, that's obviously a factory stuff up. Hey there, Glyn Watkins. Let's see, were these people even talking to me through... God damn it. Close. I'm fairly sure they spoke to me on Facebook. It can be frustrating sometimes trying to remember where it was that you were speaking to people. Especially when you've got normal Facebook, you've got business Facebook, you've got SMS, you've got email, it's all over the place. be an SMS. Oh, it's Mr. Pedro. The channel just went to crap. Hmm. No, SMSs don't look right. Crap. Crappity crap. I've I just spoke to these people today, like they dropped it off this afternoon. How the hell I have misplaced who they are or anything. Normally I stick a sticker on these things immediately, but with the events of today I didn't, and now it's causing troubles already. Okay. Alrighty, let's see. Oh yeah, where's that thing that Chris sent me? Let's see if it actually can be stuck where it needs to be stuck. Oh no, not Chris. This is Craig Jedi. Sorry. Sorry, Chris. Your name's Craig. Well, that's almost as good as people calling me Daniel. Okay, let's see if we can stick it where it needs to be stuck. So the old concept is, yes, it will work. Oh, okay. So we now have a right-angle connector in here, which means I can do this. And does the job. You know what I reckon? I reckon Caradog actually assembled this one. The reason being is because you cannot pull the film off this one. Yeah, it was suggested by a few, and I just never got around to getting one. Look at this. See? This is Caradog's influence on the factories around the world. You cannot take the screen peel off. It's stuck under there. I basically have to disassemble this whole thing to get the screen peel off. Unless I try to get a fine pitch blade or something up in the top and then pull it out from the... Maybe I should do that. Hey there, Jason. Let's see if I can get it out. Actually, no. Maybe. I don't really have any tape that is going to be strong enough to pull that up. Aha! I got it. Just needed more force than I'm willing to normally deal with. Witness and cry, Caradog. Witness and cry. Rub my fingers all over it. Okay. See, the nice thing is it now doesn't reflect all the lights from above. Okay, that's great. That's nicely sorted. Excellent. I know it's not a fantastic DSO, but you know what? It does the job. I'm not using it for highly precise things or anything to that matter. I'm just using it to get some idea of what the waveforms are doing. Alright. Okay, so this is the one that this is the first one we built with the new board. And it has the INA219 on it. But we're going to stick the 237 on it, and that is going to require us to reprogram. Now, where this is going to get fun is that it may well, we're going to have to weigh up our. We're going to have to make sure we don't make the firmware too big. Because remember, we had to sort of do some tricks to get it down before. Yeah, these are the higher voltage ones. So we will be able to handle the new Apple standard. Well, I shouldn't say Apple standard, but basically the latest Apple USB-C units, they can do up to 28 volts. They'll still work on the 20 volt. Okay. Rubbish. Oh yeah, what happened to Travis? Where'd he go? Well, this was really quick. I think I only ordered these 3 days ago at best. So I'm quite impressed. That was from DigiKey. And I got a reasonable number of them. I like to get a decent number, so you know, at least it cuts down your per unit cost. Okay. Okay, so there's our second-hand 219, and we're going to put the 237 in there. Now, the only thing that will be different between this and the future board that I already have sent off to be done is the alert pin. I have at least put options in to be able to detect it or do something with it, but on this particular incarnation the alert pin is just left floating, and that's not a problem. You're allowed to do that, but I just thought it'd be interesting to try and actually see if we could do anything with it in the future ones. I'm probably going to melt that connector, but we'll see. Yeah, she's a melting. And we will preserve that 219 because I don't have too many of them at the moment. LTS 1052, is that a reference chip? I do like a lot of linear chips, like the brand Linear. Most of my product development was based on what they had. Choices. Chopper amp, okay. I particularly like that Linear's data sheets were they were pleasant to read, and they usually had a lot of good examples in them. So you didn't end up having to be that smart as a designer, you just looked up whatever Linear had and copied it. Yeah, they've got some beautiful data sheets. I don't think I've ever used a chopper amp. Oh yeah, that's right, he got kicked, yeah. But I re-invited him and everything. I unkicked him and everything. And he never came back. He said he tried, and I've definitely removed him, from what I can tell anyway, from the banned list. So I don't know what's going on. I guess he's just given up on me. I can respect that. I'd give up on me too. Why you bridge? You could have bridged on those up there. They're the address pins, but no. You had to get a bridge on useful pins. Not a lot of lead space at the front there. I suppose really it's not meant for hand soldering, but it would have been nice to have a little bit of extra. How did he get put on the banned list? Good question. He did something like comically stupid or whatever. And I warned him, I said, if you say that again, I'll put you on the ban list. And then he did it, so I put him on the ban list. And then when I removed him, he's like, no, still on the ban list. I'm like, okay. So I don't know what happened. Clearly, with great power comes mistakes. Oh, what size are you? You gotta be 402, surely. Yeah, you're a 402 cap. You're not a 603. Oh, well, that reminds me, I did finally get my 22 microfarad 10 volt 402, so these, got these ones from Mouser. But yeah, 22 microfarad 10 volt 402, so they're the ones for the 2141 boards and things like that, like the one that we left off the other night. Yeah, just had to get some 100 nanofarads. Yeah, this is going to be a very grumpy chip. Nothing will actually come up simply because it is an I2C chip, so therefore it's not going to get addressed. So it's just going to sit around doing nothing. So the first thing I'll do is I'll power this up, see if it still at least gives me the intro logo. Oh, that's stupid, Paul. That's on the ground plane. Anyway, yeah, see if it gives me the intro, which will let me know that everything else is working, and then from there I can proceed with the whole development. Yeah, Pedro, the SSDs, VREGs. Yeah, they've got the array of the 20 microfarad 10 volt 402 caps. That basically you can't get anywhere, but like I said, I've found those 22 microfarad ones, so figured they would do the trick. Give it a shot. Okay, so the meter itself actually still functions. Interesting, it's definitely reporting different data. That's clearly no data, basically. Plug that in there. And plug this in here. Okay, so we have our programming interface set up. And now we start the fun part. And the fun part will be we have to get the data sheet for the INA219, whatever the hell this is, 237, and then we have to look at how it wants to move data. INA237 data sheet. Texas Instruments. Hey, Michael Tritz. Okay, so what we're looking for is, oh man, I really, yeah, I really question my sanity when I do this. Okay, here we go. I guess we'll bring up the code for the program. So we're going to take the T212 8x2, and that's going to become the T212 INA 237 8x. See how the tree fragments. Right. So first thing we need to do is actually put in the right address for this chip. And yep, that's dun, 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 dun. I'm just gonna find the address ID. Address byte, what have we got here? Say ground, device access. What? I'm just gonna do it like that. Alright, so it looks like they've decided to pick the address of simply 70, what? No, 80? Oh, that wrong. Yeah. 124. 40. Okay, it's 40. Which is exactly the same as the 219. Interesting. They've used the same ID. I guess they figure that it's unlikely that someone would change that. Okay. We'll just change them all just so that we know we're always dealing with the right thing. But yeah, that's an interesting first thing to learn. Okay, what else are we gonna learn now? So let's see. Maybe if I actually read instead of false reading. I have this bad habit of I will just scroll through documents trying to find specific words that stand out to me rather than actually reading the document, and that results in me scrolling many times until eventually I read the document. Okay, to communicate with the 37, main device supposed to blah 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 blah. Sorry folks, I've got a bit of a rotten cough that just won't bugger off. Okay, so we get the address. Let's see. These diagrams are writing to 16-bit registers. Register bytes to set most significant byte first. So basically, this isn't too much different to the original one. Okay, what I usually like to try and find is when they have an example communication, like they have an example process. It's the easiest way, because this chip actually has a lot of different features on it that the 219 does not seem to have. Alright, we're going way too far. Okay, what I'm going to now look at, like I said, this is all because I'm trying to avoid reading the actual data sheet. It all just turns blurry, and it's worse when you're on a YouTube live stream. It really is. Okay, this is all display stuff. Display stuff, display stuff. Wait. Oh, here we go, right. Okay, so I'm writing one. That's usually to get the 1 byte address, and then I'm reading 2 bytes, and I'm stopping, and then I'm getting the next 2 and stopping. So basically I'm pulling 2 16-bit values there, so yeah, so I'm asking for the shunt the shunt value and the bus value. So let's see if that's actually still the same here. We might not actually change much. Might be able to get away with doing nothing. That would be nice. Let's see what their register values are. Let's see. Yeah, DEFCON, it really is, you know, it's like you've got to shut yourself off into a room or something like that. Okay, so here we are, straight away I can see the first problem. See, the address here is 4 and 5 on this one for the shunt and bus. So we have to adjust that, if nothing else. See up here, we were reading 1 and 2. And we'll confirm this by doing a INA237's data sheet. And the way we confirm it is that we will have a look at this data sheet, and if it has what we're thinking of in registers 1 and 2, then we know we're on the right place. I'm just trying to find the register page. Yeah, here we go. On the 219, it's on 1 and 2. So we just need to hopefully change it to 3 and 4. So this one will be 3, and this one will be 4. We might have a win. I don't know if I can get away with it being that easy, but it's, yeah, it's worth a shot. And our programmer is on USB 1. Oh, not this shit again. Why, Paul? Why do you do this to yourself? 1951. Oh, and I do that to myself every time too. Okay. Okay, we're reading dodgy values, but let's see if we can zoom in a little bit for you there. Okay, we've still got 32 volts, which makes no current sense. Oh, pun not intended. Oh, I know why. We're not even plugged in, so... Actually, no, that makes no sense either. Use the... Where's my mobile phone one? I was not a fan of USB-C, and I'm still not the greatest fan of it, but I will admit that as a general purpose power delivery system for like low power situations, it's handy. Like in this case, we just have a USB-C to Lightning adapter, and that does the job nicely for me. Okay, clearly we've got no data whatsoever going on there. Alright, that's not working. Yeah. Okay, back to programmer. Hey, Jesper Hub. So the thing that I would be looking for is maybe I'm not initializing the chip into free running mode. Let's see if it actually does run in free running mode. It's by default. Get rid of you. Make sure we get the right ones. Does it require... Usually they don't. They usually have a factory value which just gets built in. I mean, you can put it in, but it's not so okay. And the register sizes are correct too. They're 16 and 16, so we're right on that. Yeah, we just need to... The main device accessory, secondary device, secondary, blah blah blah. So that's set up right because that's 4.0. Yeah, definitely. I tend to agree with you. I'm a big fan of the mechanical connection, the Lightning mechanical connection, vastly more so over the USB-C. I mean, you know, I've bitched about it many times in the past. Yeah, I mean, completely ignoring the overly complicated USB-C specification itself, but physically, the Lightning connector style is something I really wish they'd gone with that. Expanded it out a little wider if they had to, whatever, you know, add another 2 pins for another channel, but the whole mechanical construction of the USB-C connector, I hate it, really do. B-Blood, to be honest, I paid someone to do it. That's why it's really good. Yeah, I paid a solid amount of money to get them to do that. It was a big investment, but I'm very happy that I've done it. Okay. Writing to a register begins with the first byte transmit the main device. Okay, that's what we've already done. Yeah. Yeah, sorry, I wasn't sure if that was made clear. I put it in the title, but maybe the title was truncated. Yeah, definitely I've got to do some backfilling. We're waiting for it to settle down a little bit first. You know, it's only the dirt's only just been like raked back over. So we're going to give it a week or two and let it pack down, and then we'll bring in some more topsoil and add that on top, and then we'll throw some grass seeds around to get it to actually maybe, maybe sort of work. We have to get a interrupter system for the top of the fence. I think they call it an ocelot or something like that. But we have to buy about 110 meters of it, and that's going to be about $3,000. But it should hopefully do the job. Jim, I'm going to have to double the price of everything. Yeah, we don't care about high-speed mode. Okay, I'm going to have to read about these extra bytes here and find out what the hell's going on. Actually, you know what the first thing we should do here is we will read the manufacturer ID and display that. I think maybe, maybe. Oh, here we go, configuration register. Let's check this. Let's see. Reset field, reset bit. The setting generates the system reset the same as power and reset. Reset will register default values. Yeah, so this is what I'm thinking. It should be already default. All right. Oh, geez. Okay. And as far as I know with the older code, I just set everything to default, because if by keeping it default, unless you have a really good reason, it keeps things simple. You can set the mode for continuous or triggered mode. Okay, so we want continuous. Okay, continuous shunt and bus for. Okay, here we go. We might have to set this. So B, okay. On the ADC config. Alright, that's what we might have to do. Okay, ITC. Wait, what the hell? What? Now I'm actually confused here. Bits 15 to 12, fair enough, is the mode. How's it fitting in all this? So 12, 13, 14, 15, that's 4 bits. I see how I'm getting... Oh yeah, wait, no, shit, yeah, my brain's all fried. God damn it. 4 bits will fit the 16 values. Fried brain. Defum, thank you very much for that. $16.99. That's a serious bit of pay up there. Yeah, that's just disgusting, Paul. Don't do it like that. Yeah. Jimbo, what am I? servicing the Hannibals of the world. The only trouble is I need to find out what all the other bits are, like all 11.9, all this sort of stuff. Okay, so these are all different. Geez, hey Pro Engineer. Thank you, Pro Engineer. Can I read? I wonder if I can read that register first and then mask over it. Yeah, that might be easier. So, what we do... this is going to break my size limits here. Pain in the backside. C high, C low. Oh wow, this really feels like assembly now. See things like CHC low. Yeah, that's definitely assembler from the old days. It's the top nibble that I care about. Just trying to think what I'm trying to do here. No, wrong way, Paul. Okay, that masks off the top nibble, and then we add in the... and that. That's probably a cleaner way of doing that. But in the meantime, this lets me know what I'm doing. Let's set the ADC to auto run on both. Then we have to write the damn thing back. That's probably going to break everything. It's going to be like Starship all over again. Boo! We're out of memory space. I'm gonna have to kill my beloved little string here because that's just sucking up too much space. Oh, still too much? Really? Ah, finally. Unfortunately, we still actually don't have any activities. Alright, so since that's failed, we're now going to go back to basics and we're going to read the signature of the device and make sure at least we are communicating with it. So okay, manufacturer ID is at 3E and it should be right. Okay, so 3E. I know this is going to be boring, but such is life. Yeah, if we get 3E, we'll now be getting somewhere. Oh, lordy. I don't know what I've broken there, but I'm sure the compiler will tell me. No need to think, the compiler will tell me. Okay, and if we switch to above, we get the dreaded FFFF. Which means we upped up. Bugger. Okay, why are we not reading? Okay, one thing I better check is, do I have my lines screwed up? Do I even have actually the right chip? Yeah, I do. Let's check the pinage. Data is 4, clock is 5. Let's verify that. Actually, you know what, I can just get another circuit board instead. It's going to be real annoying if I got those swapped. Yeah, I got pull-ups. You can see them right there, actually. when I've got those populated. Okay, data's 4, data's 5. Okay, so that one. What am I saying? Okay, clock is 5, which is that. And that comes through to pin 3 on the 219. You watch, it's going to be data on pin 3. I can guarantee it. It's going to be it. It's going to be it. Yep. So I bet you I got them swapped. I think. Is that right? Data on 3. Okay, data on 3. Going to pin, the bottom pin. Yep, I got them swapped. That's what's wrong. Shit. And that's a bigger problem than I want. It's a big problem because I can't... I basically would have to cut it here to swap them, because this goes off to the display. They're all on the same bus. Oh well, let's give it a go. That's a dumb mistake to make though. Really it is. Big fat dumb one. Mega dumb. Oh well. Okay, what I can do is I can just sort of go from here to there. No, I can't because they'll feed back in there. Ah, just rip the traces up, Paul, and redo it. They need to make a special component called the crossover component or something. And you can just stick it on the board and fix up these F-ups. Okay. But hey, at least we were pretty quick on suspecting it. No, we didn't spend all night going, what the hell is wrong with this? We just spent some of the night. Yeah, Greg, like the old breakout boxes. Oh man. A number of times you'd be pulling your hair out over something stupid with the INA237's. Well, yeah. I could just swap the... You know what I could do? If I really didn't have a choice with the physicality of it, like I couldn't touch it, I could make it that it would swap the pins between the transactions to the LCD versus the transactions to the chip. I'm not sure how well it would appreciate that. It's quite possible that some data output from either source would actually cause the other chip to do strange things just simply because it happened to get lucky and clock at the right sort of rate. Yeah, there's all sorts of weirdness that can happen when you do that. There you go, see, bus corruption. But assuming you got around that, like I said, there would be situations where the data set would happen to sufficiently replicate a valid clock signal and request. That sounds like a good shirt, actually. Oh yeah, bravo, bravo. Let's just break the connection and then just bravo. Oh. Far out. Friday night, folks. I should be killing zombies. That's funny. I break the trace and then I go and stitch it back together to the same way. Idiot. Let me tell you, this is what it's like to work with half a brain. Believe me, you know, even years of YouTube live streaming, there is definitely still a good portion of your brain that you don't get to use, and subsequently you end up with screw-ups like this a little more frequently than what you're comfortable with. I need coffee. I concur, I need coffee. Thank God for Litzwire. Okay, it's probably just this specific version of the Litzwire, but the ease of which it sheds off its enamel is very much appreciated. Well, I guess we're going to get a bit of crosstalk on that one. Haha. Okay, so at this point we're still looking to see if we get... We want 3 or whatever it is. Yeah, that's right. Well, I may as well just plug it in this way. There we go. That's it. 5449. That is the correct value that we're seeking. So, yep. And at least we know the chip's working and the display's working. God damn it, I wasted $2 on a circuit board job. I should have... Didn't have the damned ground line problem, but... Oh well, there's always something. That's why when people tell me they can produce boards first time perfect, I'm like slightly skeptical. It's like, really? I don't know, man. Sounds suspicious to me. Alright, I have a feeling I might not need to do the initialization thing. I have a feeling it should be by automatic. I should just check the data sheet. I know some people can do some boards, but for the most part, most humans cannot generate a production final board on their first spin, unless it's essentially a hello world board. And a hello world board is basically a LED. Yeah, creature, I don't know. I think there's still a pretty good chance that for any reasonable level of complexity, you're going to have issues. There's going to be something... I mean, you look at any circuit board that you get, and there's always revision. It's always revision 1.073 or something like that, you know. And if it's not, then it's got bodge wires on it. Just like mine's got bodge wires on it. Jason, yeah, as long as we don't land on it when we're having a fight with a person from Iran. Okay, oh good, this is looking good. There we go, that's the sort of values we want to see. Okay, come on. Not quite. Okay, values aren't quite right yet. We are getting some sort of behavior there. We're not getting current. It's definitely charging though. But at least we're getting something. We're getting something. The battle for our planet and its began when Earth fell. What the hell? pal. You are not approved to make any noise like that. Stand down. Okay. It's why we're getting no current data. Okay, what are we looking at? 3, 4. Shouldn't that be 4, 5? That's going to be 4, 5. It's going to be register 4, 5. Almost certain it's 4, 5, not 3, 4. God damn, why don't they just have a page that says registers? Yep, 4, 5. Okay, that's why we had 0. Ooh, it's looking good now. Okay, 0.8. I know it seems silly, but since I plug this in, it should. Okay, the values are all screwy. Well, I've got both values, but they're screwy, so I'm kind of wondering if I actually got them backwards. Okay, so what do we got? Shunt is 4, bus voltage is 5, is that correct? Shunt is 4, bus is 5. Yeah, that is correct. Okay. Differential voltage, measure across, 2's complement. We already do the 2's complement, don't we? Pretty sure we do. Yeah, they're both 2's complement. Let's see, 5 microvolt a bit, 3.12 a bit. Maybe my values are wrong. Okay, once again back to the actually it would make sense that I've got a ranging issue, because obviously one of the reasons why I've gone to the new chip is because it can take a much higher voltage. So shite. Let's see. Okay, here we go. 10 microfarad for the shunt, 10 microvolts for the shunt, and this one is 5 microvolts, so we need to just double it, and the current will be similar. So this actually only needs to be divided by twice. That doesn't seem right. It should be 4. No. No, 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 no. I'm misreading this. Yeah, that's right, because that's the shunt, not the goddamn voltage. Okay, here we go. 3.12 millivolts. That's what we actually meant to do. I'm getting my lefts and rights all mixed up. Okay, so this is wrong. If we get a divide by 0, then Starship has made it into orbit. Okay, the brutal way to do this is we just simply from here we can multiply. See, when you're dealing with microcontrollers like this, a very limited amount of space, you use shifts and stuff like that rather than multiplications. So, what have we got? 3.125 per bit. Yeah, 3125 per bit. So what we would normally do here is we would normally go voltage equals 3.125. Not quite, more like 0. That's what you would normally do if you had a sufficiently powerful microcontroller. So we're going to see if that will work. It won't. I can tell you that right now. Creature, you can go to hell with your suggestions of a more powerful microcontroller. Go to hell with that. That's the chump's way out. There. Yeah, that's Micro's insulin. I'm going to go do that. And you can all sit on your hands in the corner with the dunce hat on for suggesting using a more powerful microcontroller. Where's the fun in that? Boo! Alright, sorry about that. Micro has been particularly disinclined to have his injection tonight, which is unfortunate. Alright. Anyway, so yeah, trying to do it this way is simply not viable on a tiny controller like this one. So we have to find a integer way of coming up with the same result. So let's see, 3125. What is that division factor? Let's have a look at the MS and LSB values that it proposes for the ADC. And sometimes that can give you an idea. Okay, so they're saying, okay, so you see they've got 40 volts, plus or minus 40 volts, so 80 volts across the 16-bit. Oh geez, I can never remember. It's yeah. 65535. That's all. Yep. So we got 80. Come on. Oh, what the? You really want me to type it in this way? Lousy. This is why no one uses you anymore. Xcalc. Where the hell is your division? Fuck you, Xcalc. No, where's the inverse button? God damn it. Really? Where's the inverse button? 65536. Fine, we'll do it the right way. Okay, that doesn't make sense either. So it's definitely not that. So what have we got? 1/320th. Well, if it's 1/320th, we could always try to divide by 320. Though that actually doesn't usually work out any better. In fact, it usually is worse. No, shit, it actually worked. Yeah, the voltage is all wrong. Why is that wrong? There's some really disgusting ways I can do this. Genuinely disgusting. Here, let me show you how you do disgusting programming to solve problems that your brain can't work out. Prepare to be horrified. Really, you're gonna just grimace at this one. Gutter coding is probably about it. Now the trouble here is that I don't have a sign bit, so that's a bit of a problem. Oh, that's right, it's a 2's complement. Well, that's actually right, that's how it should be. This is where being on YouTube Live is bad, because this sort of stuff I would do normally without major dramas, but for some reason, when it comes to being on YouTube, it just is a frickin' nightmare. Anyway, O equals 0. Oh, we already got that one. You ready for this? You ready for this? You're not going to be ready for this. Should I do this? Yeah, go on. No, it's not going to work. You need intermediate value. Because we've got plenty of time. This thing can spin pretty hard. You're wondering why I'm doing split like that? I found sometimes compiler will not generate correct code if I do it one big lump sum divided by a million. It's not even the right value anyway. Alright, so what we do now is we go back to first principles of bollocks. Oh, what have I got going on here? Oh, I've got some goddamn scaling going on here. This is what's throwing it out. Voltage equals... where does it say 5 microvolt a bit for the actual voltage? Damn it, I can't do mu. Yeah, here we go. 5 microvolts. That's the shunt though. We're not looking at the shunt at the moment. The shunt, that's kind of an easier one. Because from that we're getting our current. Crap, I've lost track of the chat. That's always a bad sign. Oh, here we go. Bus voltage. There we go. Right. Yeah, so the bus voltage is the one that's sort of throwing us a bit. But I've just worked it out. We just divide by 8 after we multiply by 3 and then add whatever it is divided by 8. So what we do, here we go. So we've got the... Honestly, what in the hell, Paul? What are you thinking writing this crap? Anyway. So, voltage times equal 3. So that gives our 3 millivolt part. And... no, that's not right. There we go. Let me guess. Oh shit, man, that's what I already had. That makes no sense. Okay. Somehow that voltage looks about twice what it is actually meant to be. That voltage there is about twice the value it's meant to be. Something seems wrong here. Yeah, DEFCON, that's the easy way if you don't do the integers. Yeah, if we had a microcontroller that could do it, we would do it. Okay, that looks a little more realistic though. I would have sworn this was doing 9 volts, but we'll see. We'll plug a... Actually, no, that is correct. The voltage is now right. We'll plug a MacBook in and see if it gives us 20 volts. I don't know whose MacBook this is. Oh, it's mine. Right. Okay, yeah, we've got our voltage right now. So that's all good. The current, on the other hand, yeah, that needs correction. But the voltage is correct now. But yeah, DEFCON, when it comes to these teeny tiny controllers, even though this is not the smallest controller that I've dealt with, you have to do crazy BS like this. Now we do the current. But the current, at least we know, is 5 microvolts division a bit. Shunt voltage times 20. So that should be divided by 25. That makes no sense. Robert Cook, the reason for going for the 237 is so that we can have the higher voltage and current ranges. Okay, sorry, I'm just checking something here. Please stand by while I make an idiot of myself more than usual. Okay, we're drawing about 1.4, 1.5. Actually, I could just chain these anyway. Okay. No, wrong one. Okay, so what are we showing? We've got 1.8. I really need to get myself a constant current drain, a constant load rather. This is our reference. Well, the trouble is, we actually need to concurrently do it. I just realized. Anyway, 1.8 just came up there. We have to do it concurrently because the current in the what do you call it, in the MacBook will change over time simply because it ramps up. So what we will do, finally we'll actually make use of some crappy old, let's get a wide mode. I'll find one of those crappy old ones that I've got. Hey TV, we'll put this one to some use. I think this is output. Not a fan of these. Well, I could have been, but it didn't work out. Yeah, precisely for this reason. I've got to put it the other way around. So I'll get voltage on this, but no current. Because it wants to be the other way around, and that's why I didn't use them, because this has to be plugged usually into the source. Okay, so that. And I have no idea why they didn't make it unidirectional. Anyway. Okay, they're... Wait for it to try and stabilize. I am getting very conflicting values here. I need it to frickin' stabilize. The voltage values are... what in the hell? Cancel. The voltage values are close enough, but the current's definitely off. So I'm down by about 25%. No. And 20, yeah, about 25% down. Okay, I've got my math slightly wrong on the current still. Let's see if we can just rig this up so that I don't have to keep messing around with it. Oh, this goddamn plastic peel. There we go. I'm going to sit here and look at my code and think, what do you do wrong? 20. Alright, now we're syncing. Yep. Okay, that they're in agreement pretty much. 2.3, 2.3, 1.9, 1.8. That's the sort of accuracy you can expect. Which is why when it comes to these devices, honestly, anything more than one significant bit, you're just dreaming. Yeah, we got it. And the mistake I had there was, okay, so multiply by 2, divided by 20, so you merge those together and you're going to get 10. So, R1, that would be the merging of the 5 microvolts and the something else. Anyway, above. Okay, there we go. We're still in agreement. Yes, there is an accuracy difference between accuracy and resolution. Yes, absolutely. Accuracy is how close you are to where you're meant to be. Resolution's how finely you can define how close you are, roughly speaking. The dartboard illustration is good for accuracy versus precision. At least I always found that to be a useful sort of analogy. Alright, so that's working. I'm happy with that. So, apart from the fact that I've sent off $2 worth of dodgy boards to be spun, which I can't stop, and I'll just have to send off another batch now. Yeah, that's okay. These things happen. At least it was only $2, nothing more. Warren, I am going to put up a fence around other parts of the house, but overall, to finish the house off in terms of fencing the entire perimeter with that colour bond will cost us in the region of $45,000. So as you can imagine, I'm not really hauling that kind of cash right now. Not even close. Not even freaking close. Alright, so I guess we should now see if we can introduce the important parts of this setup, and that is, of course, the intro strings. It's gonna tell me to go to hell. Come on. Oh, what to give up? We'll give up this one. Oh, it just managed to fit that in. Impressive. So we'll do the reset. Here we go. Now the next thing, oh, I just realized this is going to completely mess with the data translation on the on-screen display. The reason being is because in order to reduce the amount of overhead and all that sort of stuff, I just send the raw register values to the on-screen display. And I do not have a way to differentiate at this point between the 219 and the 237. However, it's not a big issue because really I've not actually produced or sold any of these to anyone yet. I mean, there's a couple of orders that want to be taken up. So I can just assume that I'm going to make them and sell them all as 237's. So I don't really have a problem here. If I want to, I can put like a single character prefix to designate what model I'm dealing with. It's like when we send out our serial string here, which all this jibber jabber here is generating the 32 bits of data, the two registers, as a 4-byte string. Just 8 hex characters. So what we can always do is we can actually just prefix or suffix an extra byte in there. It's not a huge penalty because we're not stuck for performance on this. So we can always just stick something on there. Jason, this is a USB-C meter. What I might do... oh, damn it, Jason. Yeah, I don't know why I can't get your humor, Jason. It's kind of distressing. I could change the line break to something else, because that is somewhat redundant. So like instead of a /n, I can use a /r to notify that it's a different model. But it wouldn't hurt to have some sort of identifying byte right at the start anyway. Well, Stephen, in terms of byte size, the amount of data that gets pumped through, they're actually the same. They're still 16-bit only. So it would really be a case of indicating a 219 versus a 237. But I suppose, N or W, that would work. It seems unfortunate to have to repeat it, though. Let me think. I can just change that line break to something else, because it's not really required. It is a useful delimiter, though. Yeah, we'll just stick a byte at the end and or at the start. Choices. Okay, I've got plenty of space. That can actually be reduced down to quite a bit. That could be just down to 10. What about picking up the data length decode from? Because it's still always going to be 32 bits of data. Like whether it's the 219 or the 237, it's just 32 bits of data no matter what, because the registers are all the same size. That's the kind of the convenience that this chip had in terms of jumping up from the previous version, from the other version. Where is it? Yeah, so if you look at the register size, they're still 16 bits only, so it doesn't matter. So yeah, you have to sort of throw that extra bit of data in if you want to be able to make it different. I think I'm going to do it because it will make it slightly more future-proof. I say slightly more future-proof because it's 1 byte doesn't give you a huge amount of headroom. The other way you could go about it, if you wanted to... No, well, I can't. I was going to say I could look at the most significant bits, but then the way that these chips work is they actually utilize the full 16 bits. So there's no like spare bits either way. So now we can't do what I was thinking of doing. Oh well. Yeah, we'll just add 1 extra byte. 1 byte a picnic doesn't make it. If it's a big byte. Now the question is, do you prefix or suffix? I think we'll prefix just to make it hellish for everybody. Alright, so now we've got to decide what's our byte going to be. There was a good suggestion before by Stephen saying, W or narrow. Yeah, the OCD's kicking in. Narrow or wide, or we could have something relating to it being like INA219 versus 237. Or we could simply just be completely soulless and just simply go 0, 1, 2, 3, something like that. Well, let's call it W for now for wide. So we'll take Stephen's suggestion. Wide seems pretty good. Ah, crap! Pressed the wrong buttons there, Mr. Daniels. Now I'm kind of thinking maybe I should put a suffix, because if I make it a suffix it then won't break existing software, but then and there's a fault in the code there already. Some people may have already picked it up. It'll be a teeny tiny one, but it will break it. And that should be 11. ASCII code the voltage, 20 or 28. There's a good suggestion. That might win out over Stevens. Yeah, man, ASCII. Okay, so decimal 20. Device control 4 versus file separator. Well, they're not 0 bytes, so yeah, actually I like that one. Stephen, I liked yours. I did, but I like the idea of going 20 or 28 even more. Yeah. Please don't hate me. It would have beaten on poor old Steve. He's never going to come back. He's going to become like the guy that I apparently banned. Alright, that's a good suggestion, and I mean, things like this, thinking about it, it can help towards making the software a little more understandable and future sort of proofing. Okay. You'll never emotionally recover from the humiliation. Well, I'll tell you what, we can go Thunderdome style, and you and Defcom can duke it out in a cage match, and we'll have Tina Turner decide who wins if neither of you die. Alright, so that's working there. Now it's time to switch to the on-screen display software. Ooh, you know what I do? Git add. What? Just add it, you moron. Alright, now the on-screen display stuff's going to get fun. But we can actually self-detect this one, because we can look to see if there's an additional byte in there. But it is going to make it ugly. Oh wait, it's my own code, so of course it's ugly. Where it breaks things a little bit is going to be on the port detection. Okay, see where we find a port. But like I said, I'm going to readjust the firmware anyway on the other ones. What? That code makes no sense whatsoever. Where do I write that anywhere? Yeah, I don't. I was going to say, I definitely don't have that anywhere. Ah, here we go. Right, this section here is actually redundant anyway. Oh yeah, definitely that's true about the code. Okay, so what we're going to say, we actually need a frame size of 9. And then what we're going to have is if serial buffer 8 equals 20, then OSD mode equals OSD, and that should be lowercase. Thank you. Standards, Mr. Daniels, standards. Okay, so now we're going to go and create that damn variable. Pump it into some global. There we go. Yay, I got globals. Thank God for that. And then what we do is we're going to optimize our code. We could actually improve on this and just simply go, yeah, let's do this. Ah, type properly. Okay, so because that's not going to work either. No, no. Undo that. Yeah, this is where you start getting pedantic about things. We'll leave that for the moment. Okay. Hey there, Miles. Shots fired. Shots not received. Okay, now I need to plug this in. Right. Of course not, because it's a global. I mean, it's in the global structure. It's not actually a global 463. Okay, Mr. Daniels, you must close that old source because it's going to confuse you. Okay, GLB, right. What? Expecting that? That makes no sense. Didn't think so. I thought I'd globalize the global. GLBS maybe? Ah, it's supposed to be GLBS, right. You're killing me, man. Thank God. This is not really my preferred development workstation, so I'm making a lot of keyboard mistakes. That's my excuse and I'm sticking to it. To hell with you all. Resource temporarily available. That means I've probably got it running somewhere. Nope. Oh, no, that's right. Yeah, cool. We're on USB 1. Oh yeah, here we go. Alright, so the values are wrong there because, you know, it's not interpreting the data correctly. But at least it's a start. So now we have to translate the data based on what we've got here. Okay, voltage quanta. Okay. So we're gonna have to change this to a variable now because it will change according to what mode we're in. And there's no point putting it on the inside of a loop because it's only going to be done once, basically. .37. Okay. 004. This we need to change. Nope, something's still wrong there. Okay, I think I know what's wrong is that even though our sensing when we're detecting the port is smart for the 9 byte thing, the actual reading is not. So what am I doing here with this? Yeah, this would mess it up badly, I think, maybe slightly. No, still wrong. Hmm. We'll run it with debug. Okay, so 1C, that should be 28. There we go. Okay, so we know we're definitely generating the right data because we can see the suffix there indicating that it is the 28 volt mode. So we've got 6361, 31, then 313. Am I misinterpreting something here? Clearly. Alright, the easiest way around this is that I will plug in the known working unit, although it's not going to pick up the... I've got myself into a trap here. No, it's okay. Carry on, Mr. Daniels. Let's try this. I just want to compare the values I'm generating. I have a feeling this won't actually pick it up. Yeah, it's not gonna pick it up. It's always fun. Okay, how about this? Kind of breaks it short term, but it'll let me get the data that I want, I think. got bitten again by that. Alright, great. Cool. We've got our data. Funnily enough, it reads perfectly fine. Okay, so yeah, 65, 61, 39. Okay, so basically we just look at these two values here. They're correct, so that's good. So we know that the new board with the 237 is generating valid data. So we know that, so that's good. It just means that we're translating it incorrectly. Although that's wrong. 6331? I thought it was 6339. Oh, actually, no. It makes sense that these values are different because remember, they are scaled differently. Yeah, okay, that's fine. Hey, Mr. Brown. Good morning to you, sir. Okay, so 28 volt mode is being selected, so that's good. Now we just got to work out why we're butchering our data. That does actually make a lot of sense, to be honest. Let's see if I'm 003125. So I mean that, you know, that's not too far off, and 3636, that's also pretty much on. So I'm not sure why it's been quite so butchered, unless I'm... See, data start, data start. Well, we can brutally kill it just simply by going serial buffer 8. So that would actually make it, should make it behave the same regardless. Yeah, I'm a bit confused by this. Okay, DevFom. Actually should... Yeah, no, that's right. Oh, no, yeah, no, yeah, God, I feel like Fry trying to pick between a bunch of lizards and a parrot. Again, don't know, what's going on there? Let me just... Yeah, Warren's still here. 11:30. Like I said, the data doesn't look that much different. The current should be the same, I think, though, because they're both 5. But at least the voltage... Yeah. You gotta hate it when you feel like something's just looking you dead in the face and you just can't find it. Yeah, transpose something. Or something like that, yeah. Okay, the ordering of the data is correct. It'll be something where I've hard coded a number in where I shouldn't have. This shouldn't be required anymore. Yeah, let's rip. Oh, the hash define I could remove simply because of the fact that I knew that it would, it wasn't present anywhere else. What gets me here is the voltage almost looks like the... No, the voltage is not the current. No, ignore me. I mean, when you look from above, you can see it's translating the data just fine. Oh, okay. Shift to the right. That doesn't fix everything though. Okay, we've got the voltage up now. The voltage is doing the right thing, but the current's wrong. I might just... You know what? If... No. That might have been causing problems because that's actually a bit that gets set when the voltage is out of range, but that might be specific only to the 219. Okay, so we're a little more stable there, but our current is still completely butchered. It'll be something stupid. think I know why. That current quanta is wrong. That is giving us that there. That will actually just simply give us the voltage across the shunt. So this actually then needs to be multiplied by 20, I think. Whoops. Yeah, give me it back. And that would actually be correct. So, yeah, you can see, yeah. The LCD is only updated every 5 frames, so it will be slightly out of sync, but you can see that it's working. No, I actually kind of like it being fast for the on-screen display. The reason being is because I want to really see any sort of wiggles and behaviors when I'm doing diagnostics. I mean, I suppose I could put a averaging sort of thing in there where it just sort of like, does the same as the LCD, and it only updates every 5 frames, but it keeps the graphs updated per frame. I mean, that could always be an option. Alright, so that works for that, which means it's probably now very broken for the other one. Sorry, folks. Please stand by while I reset my throat. Try a negative voltage, see if it... Well, the way you get the negative voltage is you just... Actually, I don't have a negative voltage anyway. But, I can flip them around and the current should just simply swap around. There we go. Yeah, it uses the chevrons to indicate which way the current is flowing. Okay, so what we need to do is we actually need to change the current quanta up here in the 28 volt mode to be times 20. Alright, so that's still working. And I really shouldn't care, but I'm going to swap in the 219 model. Like I said, I really shouldn't care, but I do. Because like I said, I'm going to reflash these 219s to produce the proper bitage indication. So let's see what happens. Yeah, values are slightly all screwed up now. So this should actually be the same. No, it's not. It's about half what it should be. Okay, let's go back to the data sheet. That's not the data sheet. Okay, 219. Stupid thing is, I had it before, but I butchered it. It's because I want to make it so I've got it consistent between the two values. Here we go. Okay, so shunt voltage on this one is 10 microvolts per unit. So yeah, that makes sense then, because that would be... And so you can see the current is correct now. And we just got to fix up the voltage one. So yeah, the voltage is slightly over the top. And again, go back to the data sheet. Where were we? And oh, that makes it's 4 millivolts. Okay, that is what we had, wasn't it? Oh, interesting to note. Okay, the accuracy is actually 12 bits on the 219, whereas the one we've got now is 16 bits, right? So on the 219, we could have actually padded something or used the high bits to indicate something, but we can't with the 237. Anyway, so we have 4 millivolt on this one. Hey user, sorry I wasn't... that's weird. This one is... It is 4 millivolt. What am I missing here? Everything's better... No, everything's better in 64-bit. I'm actually not sure what's going on here. Yet. Oh, I know what's going on. Okay, that 12-bit versus 16-bit, that's because it's left padded, left shifted, so I actually have to right shift it down, so that's why. And that's what that shift to the right 3 bits was. And so what we do here is we go if, we can merge this in later anyway. Can't do that. Well, that's offensive. What? Oh, my bad. Okay. Alright, now we have proper value. Alright. Yeah, so basically what that is they just, bring all the bits that they have, all the significant bits, off to the left of the block of data that they're sending through to you. So you start with the most significant bit. And so what was happening is I would read that data in, but then I was forgetting to shift it off to the right. Anyway, it's done, it's working, we're good. Hey. That was more fun than I planned, but it always is, isn't it? Every time I bring out some new thing, it's like, oh shit, here we go. Paul's gonna spend the whole night turning that 5-minute job into a freaking disaster. But we got there in the end. There. Yep, it's ready to go. So, yeah, basically, I think I might not even bother. I'm trying to decide. Yeah, there's a couple of people who have already ordered these, and they're eager to get their hands on them. But honestly, I think I'm just going to make them wait a little bit. I'll pay extra to get faster shipping on the new set of boards, and the new set of boards will have the chip uncrossed, unlike the one I've got. So, but it's all good, because it's kind of better if I can simplify the software so that it only has to work with one mode. But we will leave that mode indication byte in there. I think that's useful, maybe not just for now, but for future modifications or expansions we make. Yeah, so I think if they can wait, we'll ship out all the good 237 models instead. New mistakes coming, definitely. Yeah, see you next week. Alright, listen, I've got to get out of here. I've got other programming to do upstairs. Thank you all for watching, and I will see you all next time. If you are interested in getting one of these boards, just send me an email, and we can put you on the list. I sort of don't know what I'm going to do about mass production of them, because yeah, I just don't know. I mean, I really don't want to be. I would rather just simply say to a factory, look, make these, make me 1,000 of these, and then people can buy them. Signed and numbered. Yeah, kit form, oh hell no. Kit form can go to hell. Hey there, 3X. Alright, I'm out of here. You all take care. Thanks for watching. Thanks for tolerating it. I'm glad I got to yell at some of you, and I will see you all next time. I'll catch you later.